Good afternoon, everybody. Welcome to the Eco Stage, powered by TLMI. I'm Rosalind Bandy, and I have the privilege of leading sustainability for TLMI. We have a wonderful agenda of speakers. We have got a couple left for today, and then all day tomorrow, 10 to 3, and all day Thursday, 10 to 3. Check out our agenda because there is something for everyone on the topic of sustainability. So right now, I'd like to introduce Mike Ferrari, who is president of the Consortium for Waste Circularity, who's going to tell us a little bit about the sustainable future of the printing industry. Mike?
Rosalind, thank you. Appreciate that. And of course, best for last. I'm pleased to be here today. A little bit about myself. I had a 32-year career with the Procter & Gamble company. So I was the one making a lot of the packaging waste. And as of 4 years ago, I was introduced to a technology called robust gasification by a professor at the University of Florida, Dr. Bruce Welt. And from that time forward, I have really been joined and believing that this is a technology that has not only a lot of promise, but will allow us to become circular. So I want to share with you today what that vision is. We have created a nonprofit at this point in time called the Consortium for Waste Circularity, and it was founded by people just like you in those seats, by printers who believe that there is no other solution. So with that, I'll start and want to talk about specifically what are the challenges for the label industry. I want to divide it into two groups. One is the manufacturing waste, and in manufacturing, of course, we've got matrix waste, we've got liner waste, and we have flexo plate waste. There is no recycling opportunity for flexo plates right now. They're cross-linked polymers. There is no infrastructure. They're either burned or landfilled. And of course, there is some effort to try to reduce the manufacturing waste of liners and matrix waste, but not much is going on in that camp. The other is the post-consumer recycle of what happens at the consumer side. And things like tubs, things like shrink sleeves also have no solution. So it's both sides of the equation, the manufactured waste and the post-consumer waste, that we need to be concerned about that labels go on to. Recycling should not be difficult, but it is. And here's an example. For plastic recycling, we only have infrastructure for plastics number 1 and 2, but there are 7 grades. And then there's all kinds of other options when you look at laminations. Paper and cardboard, and then some of you may have the ability to have food waste recycling, but not everybody has that. But here's what the EPA says about these, is that the recycle rate of what you put into your recycle bin for plastics alone is 9%. 91% goes into landfill. There are independent NGOs that have actually looked into that number and claim that it's more like 3.5% to 4%. Doesn't matter. It's such a small number that something needs to be done. But paper has been recycled for a very long time. And it's the most highly recycled of all the material classes. It's at 68%. Should we be happy with 68% being the highest? Because it means that 32% still goes to landfills and incineration. Food is 44% going to composting, and 56% that is going to landfill or incineration. So I'm sharing this because these numbers should be troubling to anyone, and these are the numbers about landfilling. Now, when we talk about plastics, the media has picked plastics to be a bad actor. And so many folks talk about banning single-use plastics. Many folks associate plastic with ocean plastic. Well, it's not just plastic that's ending up in the ocean, it's everything else as well. But I think we combine two different problem statements there, because what is happening on land for recycling and what is happening in the oceans are about litter. And that's a very different problem, and you need a different solution. But what I like about this chart and what I want to share is that the Imperial College of London has examined 73 LCAs on plastics and found that plastics always come out as the lowest carbon footprint. So when I hear that there is a move to get away from plastics to something more sustainable, it typically, according to this chart and the LCAs from around the world, would actually produce more harm to the environment than keeping plastics. So bashing plastics will get us to the wrong solution. From the EPA, here is the pie chart of what is going into landfills. And so you see the big pie for food, and the next biggest one, plastics and paper. Everything on this chart, with the exception of metal and glass, which is less than 15%, is organic. Now, what does that really mean when I say it's organic? That means that it's a carbon atom and a hydrogen atom. When we have carbon and hydrogen, we will be able to extract that. It has value. And the only thing that doesn't is again, the metals and glass. So of everything in our trash, what I'm about to share with you is that 85% of what is already in landfills can actually be put to productive use. So before I go further, I want to really cover the problem statement. If you think very narrowly and really just take out one material class or one specific type of the 7 grades of plastic, you're really incrementally making a change. What I think we need to do is make a step change, a disruptive change. And the only way to look at that is to look at the problem statement. So we at the Consortium for Waste Circularity are really looking at landfills. No one material class, all the material classes. And it's about the fact that landfills are filling. They're especially filling in the urban areas, on the east coast of the US, on the west coast, and of course we have the majority of land in the center. So what happens when a New York City runs out of landfill? They put it on a train and ship it to Ohio. What have we, what are we doing here? So looking at landfills as part of the problem statement, looking at the greenhouse gases that come from landfills or incineration that then directly impact climate change is the second part of the problem. And lastly, the big part of the problem, you heard from the speaker just before me, if you were here, the US Plastics Pact, that there isn't enough recycled content. So that's another problem. So if you take that, and we at the Consortium for Waste Circularity have created a vision around that problem statement, and it's that we'd like to transform what is landfills to the way it was intended to be, productive fields. Remove the greenhouse gas effect and also take the waste and make a productive end product through a series of science from waste to syngas to methanol. And that methanol coming from the feedstock of waste will then be eco-methanol. It will not come from petroleum. So let's look at that now. Let's look at the technology. This vision came from the University of Florida and Dr. Bruce Welch that I mentioned earlier. And it basically talks about taking waste, not just packaging, but all waste, whatever is going into landfills, and whatever is left over from the recycle bin, having robust gasification, which I'll talk more about, and converting it to its elements of carbon and hydrogen. These are reformulated elements, okay? And that is the basis for many chemicals in the chemical industry. So we make synthesis gas all over the United States, but from fossil fuel today, because it's a valuable chemical. What we're proposing is that can be made from waste. And from there is where you get the methanol. Methanol is then the base chemical to make plastics. Once you have the plastics, they become waste, and around you go again and again, because you're always breaking the carbon and hydrogen atoms back to the periodic table of elements. This would be virgin material. Looking deeper at what this is, if we take our packaging with shrink sleeves or labels on different materials, we're putting several materials together, and that contaminates the stream. It makes it difficult. Or a snack bag, which has aluminum on the inside and polyethylene film on the outside. There's just no recycling for that today. Juice boxes, which are multi-layer and have fitments in them, or straws, or yogurt cups or coffee cups, which have then a lid, an aluminum lid that may stay on the plastic tub. Again, these are very difficult, and of course flexo plates, which I mentioned earlier. All these problematic, I point these out, but there would be many more than just this. These are the problematic ones, and if that were sent to landfill and we have a robust gasifier, then what we see here is a two-stage gasifier. Now, gasifiers have been around since the 1800s. And in the 1800s, it was really the beginning of gasification. Wood was used as the feedstock. Gasification occurred. They created at very low temperatures, like 400 degrees, and they created syngas, and the syngas was used for street lamps. From the 1800s to now, we have seen a constant improvement and variation on gasifiers, and that's why this we call a robust gasifier, because this is at very high temperatures. It's not incineration, not to be confused. It actually just breaks the covalent bonds of the molecules apart to get the carbon and hydrogen, and then anything that is falling, any incidental metals that might be here, fall to the bottom, just like a metal melting furnace, and you capture metals here, but all of the syngas is then captured here and converted. There should have been an arrow here, sorry about that, but you can imagine, and that becomes the recycled content, and here is the formula. And then from here is how the industry makes virgin new products of plastic. So that is the science behind it, and it's been around. It's just getting more and more sophisticated, and there are pilot plants already in existence. What comes out? So I talked about what comes out the top, which is the syngas. Let me talk for a moment what comes out the bottom. There are metals, and you can have metal ingots, which then can be used for the metal industry, or slag, very much like the metal melting industry, vitrified glass, and that has a purpose and a revenue stream as well. The vitrified glass is used and can be used for asphalt, cement, and other, the abrasive tool industry. So that can be used for that and create a revenue stream, although that's not the big deal. The syngas and the methanol are really the big deal. Here is what I call more of the business model. The real breakthrough idea here is that if you take a gasifier and you reinvent the landfill by co-locating the gasifier at landfills, whatever is coming to the landfill then can be processed. So let's start at the beginning. You have a recycle, we all have the recycle bins, and that goes through a MRF, and the MRF will get to mechanical recycling, which I stated earlier is 9% recovery, which means that in this line, there is 91% of that plastic going to landfill. The idea here is that whether you have mechanical recycling, PET depolymerization, which the previous speaker spoke of, or in the future if there's pyrolysis to create pyrolysis oil, all this is great, and robust gasification would be compatible with that. But whatever cannot be handled by these processes that will still be dumped into landfills can now be processed to something valued through robust gasification to then make plastics. Why is this such a big idea? It's a big idea to be co-located because the logistics are already in place. They're already taking it from your curbside already to landfills. So there's not a problem. No additional trucks on the road. If a unit goes down or needs maintenance, you can continue to temporarily dump into the ground and then come right back up. And over time, you can decompose the landfill, as I mentioned in my previous slide. So, if we look at the versatility of syngas today is used from fossil fuel to make all of these. And different industries feed off of this. So the agricultural industry is making fertilizers from the basis of syngas. I'm going to talk about, buses and forklift trucks in warehouses use hydrogen already, and they can feed off of that. I'm going to talk about the airline industry, but fuels is what they get. And what we're saying is the making of methanol, which is in this chemical pie, is what we need for the print and packaging industry. So what I want you to think about is that this is not an invention. This is already being practiced by the airline industry. This is very new, but it is being practiced. The airline industry, along with the auto industry, is the #1 cause of greenhouse gases. The #2 is agriculture, and #3 are landfills due to the methane that comes off. The airline industry, who's had a gun to their head around what are they going to do, we're not going to get to electric airplanes anytime, I think, in our lifetime soon, commercially. So they have decided to go from waste to actually have a process of waste to syngas to biofuels. They have already declared that by 2050 they will be carbon neutral by using biofuels made from waste instead of made from petroleum. The first plant is up and running in Nevada. It's already been through the jet engines and they run without retrofit. So my point is, that model is already there. The difference that we're talking about is just using the syngas to make methanol, which already exists today. Folks, what I'm asking here with this example is that we collectively need to be like the airline industry. We in the packaging, in the label industry, in the printing industry, the suppliers need to be like them and align. If we don't align, it's going to take all of us. If we don't align, it's not going to happen. We're going to continue in this world of incrementalism, which I state we're in right now. This is the big vision that then catches everything that can't be done. Here is a laboratory-size robust gasifier, and the University of Florida has put out, so if anyone here would like to test their materials because you have a problem, it can be tested. A number of companies have taken the University of Florida up on that, and McDermott, one of the makers of Flexo plates, was one of them. And they're okay with my sharing this. They presented 350 pounds of waste, blotter material, and used Flexo plates with ink on them, so it was contaminated. It was shredded and fed by auger into that laboratory gasifier. Here is the chart just to prove that this works. And here are the here's the syngas coming out on top, the carbon monoxide, the hydrogen. Here is basically the feed of the auger, which is the syngas flow rate. And this was actually recycling at the 90% level of everything. There's some incidental stuff on the bottom, and this is total carbon capture. There are no smokestacks with this. Now let's talk financials. Financial model, and sorry I didn't have time to simplify this, but a 200, what these numbers represent are tons per day. So I just want to focus for a moment on the 250 ton per day. If you look at a 250 ton per day at a landfill, here's the revenue and expenses, and what the number one indicates, it assumes that there is no premium charge versus the methanol that is made from fossil fuel. Now, that shouldn't be the case, because when you then make methanol from waste, you really have a premium, because now it's doing something special. This is what all the brands are after, is basically recycled content. So you see an after-tax net present value that is healthy, and if you put a 2x charge to that, you can see that the numbers go up. The point here is not to debate the specifics of the numbers, but to say that the numbers are positive, which means no government subsidies are needed. This is a business that can occur, and we are moving toward a first commercial unit sometime in 2023. So in closing, I want to say that the mission of the consortium is to really align industry, academia, and government. It's going to take all bodies to really be concerted against this. And so I'm here to really align all of us to really come into the organization to support this vision, not to stop other things that you're doing, but to add this as an and. This is the long game, but it is possible, and it's disruptive. And pledging against the use specifically of ecomethanol. Ecomethanol will then allow, because it's virgin content, it brought carbon and hydrogen back to the periodic table of elements. It will allow the food industry, the medical industry, the beverage industry to have product without contamination because it's virgin. And lastly, the mission is that we actually fund research and development and outreach on this vision to start moving this into commercial space. So what can you do? What I would ask, I have 3 takeaways here. Number 1, join the LinkedIn page for the Consortium for Waste Circularity. Be part of the conversation. See what's going on. That doesn't cost anything. If you have any materials and you really would like to test, not only will we test it, but we're going to invite you to be present during the test so you can witness it. Because people that have witnessed it have come into the consortium. That's what McDermott did. And lastly, join the consortium itself. Become a member or a sponsor. Today's waste can be tomorrow's ecomethanol. It's reality. It's science-based. Thank you.
Any questions for Mike in the audience?
I really appreciate your excitement around this exciting technology. How will the methanol get into plastic form?
I'm sorry.
How does the methanol become plastic?
Okay, so there is an methanol to olefin process. Honeywell is one of the licensors of that. China is, by the way, one of the reasons China stopped taking it is because they're using the MTO process, methanol to olefins.
Other questions?
Mike, the recycling process that you're describing, where is it done physically, and is it also possible in Europe, in other parts of the world? So where can we see it to join and to bring all the waste?
Sure. So I mentioned earlier that there are pilot plants here in the U.S. There's also pilot plants in Europe. And the answer to your second question, which I'm excited about, is absolutely, this is global. There is nothing to say that this is not for the entire world. So absolutely, this is reapplicable. I certainly would like to see the first copy here, and then from there, duplicate. I have a lot more I can say about that, particularly about the financials. The insurance companies are into this. We've been contacted. As soon as the first commercial gets an A rating, private funding will take over.
Anybody else?
Sorry. What items can't be used in the stream? Is there anything that will poison or contaminate that you have to screen out before you go for your gasification?
Great question. So, from a harm, that's really a great question, because the answer is no. Nothing needs to, so it can take unsorted waste. So whatever ends up in landfill, now I will say, if you recall, I was very specific about the organics, things that have the carbon and hydrogen. So I'd prefer to have as much of the organics as possible, because that's what's making the methanol. I'd love to have the incidental metals. What I think we can certainly keep out of there, because it's not very productive, is the glass and the metals cans. But that's normally screened anyway.
I think back when oil was about $125 a barrel, a bunch of companies tried similar technologies. Range Fuels, I believe, based out of Colorado. They tried this. I think they went bankrupt. And the technology, just all the inorganics would foul the system, would corrode the metal. How is this technology different? How are they overcoming that?
Great question. So, two things. What happened in the so it was the early 2000s when robust gasification was able to get up to those high temperatures that is part of the secret of all this. The very early attempts were to use waste to syngas to make electricity. That's a non-starter, because the cost of electricity in the U.S. is so low you cannot pay out the financials. So that's one. The early versions of gasification also had some thermal problems, and so you'd have some hot spots, some cold spots. That has been solved in the last 22 years. It's moved into having a better distribution of the heat.
Mike, another one. If it is as good as you say, why isn't it taking off like mushrooms, and it would solve a lot of problems for all the city halls that they don't know what to do with the waste?
Yeah. So, number one, it is happening in the airline industry, and it's taking off there. There are 4 more plant sites for biofuels, so it's taking off. What I'm suggesting is that we also do this for the printing and packaging industry to get the recycled content of methanol. But there's a high capital cost, so that has certainly prevented people from putting in a first commercial unit. But we are moving in that direction. There's enough pain right now, and I think as time goes on, more and more pain is felt, that people are stepping forward to want to finance the first one.